Hello and welcome to In Simple Terms with Satish. Today we are talking about MCP authorization for AI agent tools. This matters because AI agents are not only answering questions anymore, they are starting to use tools that can read data, search systems, create records, update files, or trigger workflows. Let us understand this with a simple everyday example. Imagine a contractor comes to an office building to fix one conference room. You do not give that contractor the master key for the whole building. You give them a visitor badge. That badge opens the front door, the right floor, and the right room. It does not open the finance cabinet, the server room, or the CEO's office. And if the contractor suddenly needs to enter the server room, someone should approve that separately. That is the right mental model for AI agent tools. Now coming back to technology. MCP or Model Context Protocol lets AI applications connect to external tools and data sources in a more standard way. In the beginning, many MCP tools were local. They ran on a developer's machine and talked to local files or local programs. But the more serious pattern is remote MCP servers. A remote MCP server might expose tools for documents, databases, repositories, calendars, or internal APIs. At that point, the MCP server is not just a helper function, it is a protected resource. So the agent client needs authorization before it can call the tool. And not just any authorization, it needs permission for the right resource with the right scope for the right operation. The flow is roughly like this. First, the agent client tries to reach a protected MCP server. The server says in effect, you need authorization and here is where to learn how. The client fetches that authorization metadata. Then it learns which authorization server to use. The user grants permission. The client receives an access token. Then the client calls the MCP server with that token. But here is the important part. The MCP server must validate that the token was actually meant for this MCP server. A token for one building should not open a different building. A token for one MCP server should not work against another MCP server. That protects against token confusion. The second important idea is scope. Scope is the difference between you may read this data and you may change this data. For agent tools, scope matters a lot. The agent should not start with the master key. It should start with narrow permission. If the user asks for something more sensitive, the system can ask for stronger permission at that moment. That is called step-up authorization. For example, reading a document may be allowed with one permission. Deleting a document should require a stronger permission and probably a clear user confirmation. The third important idea is that authorization is not the same as tool safety. Authorization says this user and client are allowed to access this server. Tool safety asks, should this exact tool call happen right now? Those are different questions. A tool might claim it is safe, but the client should not blindly trust every remote tool description. For sensitive operations, the client should show what tool will run, what data is being sent, and what action will happen. It should ask for confirmation when the action can change or expose something important. And it should keep an audit trail. This is especially important because agents can be influenced by untrusted content. If a web page, document, email, or tool result tries to trick the agent, the permission system is one of the guardrails that prevents a bad instruction from becoming a real action. So the practical engineering pattern is discover the protected resource, get a token for that resource, request the smallest useful scope, validate the token before every tool call, use stronger permission for risky actions, Do not pass the inbound token to other systems. Show sensitive tool calls to the user. Log what happened. In simple terms, MCP authorization is how we stop an AI agent from walking around with a master key. Instead, the agent gets the right badge for the right tool at the right time. That is what makes remote AI agent tools safer, more auditable, and more realistic for serious software. If this helped you understand the topic in simple terms, follow or subscribe to In Simple Terms with Satish. I will see you in the next episode.